So we're here at the example table, and in this video we're going to rewrite the function f of x equals x plus 2 divided by the absolute value of x plus 2 piecewise. So let's just write down the definition as a little reminder of the absolute value of x. The piecewise version of the absolute value of x, well, it's x if x is greater than or equal to 0, right? If x is non-negative, the absolute value leaves it alone. And it's negative x if x is less than 0. So one thing to note, negative x, if x is less than 0, is a positive quantity, right? If x is, let's say, negative 4, negative 4 is positive 4. So this is the absolute value of x. Our goal is to get to this thing. Let's look at something a little bit simpler. Let's look at g of x is x divided by the absolute value of x. Let's rewrite this in a piecewise way. So here, we actually are going to add one condition to these two because we can't plug in 0. So that's going to be a third condition here. Now let's assume x is positive. If x is positive, the absolute value of x is just x. So this becomes x over x. If x is 0, then the denominator is 0, so this thing is undefined. And if x is negative, then the absolute value of x is negative x. So x over negative x. So I wrote down the three values of this function, but I didn't write down the conditions. This first one was for positive x, right, x greater than 0. The second one was for x equals 0. And the third one is for x less than 0. Now it's worth noting that x over x is just 1, as long as x is not 0. But this first condition is just for positive x. Here, x over negative x is negative 1. Right? As long as x isn't 0, and it's not, right? X here is negative. So this function, let's graph it actually. This function is undefined at 0. For all positive values, it's 1. So for positive values, well, let's put a little circle here. It goes like this. It's just constant, right? It's just 1. Circle is because it's undefined at 0. And for negative values, it's just negative 1. So we'll put a little circle here, still undefined at 0, and we go across. So this is g of x. We want a plus 2 in here. Now if you'll remember, plus 2 on the inside of a function, right, so let's actually make a note of that. F of x is g of x plus 2. When we add 2 inside the function like this, it shifts the function to the left by 2. Now, what does that say about this definition? This top condition is still going to apply. This bottom condition is still going to apply. Sorry, the middle condition is still going to apply, and the bottom one is still going to apply. The only thing that's going to change are these things, right? Because imagine you're shifting this graph to the left. This line stays the same, it's just shifted. This line stays the same, it's just shifted. So the only two values that this function f takes on are 1 and negative 1. It's just a question of the conditions that give rise to those values. So let's write that down on a clean sheet of paper. So f of x, which is x plus 2 over the absolute value of x plus 2, is, well, let's write down the values first. It's either going to be 1, undefined, or negative 1. And it's 1, well, the previous one, g, was 1 for all x greater than 0. To be 1 here, In other words, to make this quantity inside the absolute value positive, x has to be greater than -2. Right? For any x greater than -2, x plus 2 is going to be greater than 0. So the absolute value is just going to leave us with x plus 2, which gives us 1. Right? Just like before with g, x greater than 0, here we just need x greater than -2. It's undefined when the denominator is equal to 0. The denominator is equal to 0 here when x equals -2. And you have to be careful when you say things like this, but almost by process of elimination, it's -1 when x is less than -2. We can verify that, though, because if x is less than -2, then x plus 2 is negative, so the absolute value is -1 times whatever that quantity is. That gives us our -1. So here is our function f defined piecewise.